Hello. All right, today we look at the second type of conic section. It's a parabola. We've already dealt some with parabolas. We've just got a few things we're going to add to it. All right, let's start with just the definition of the parabola. This is something we haven't really looked at. A parabola is really just the set of points that are equidistant from a given line. In this case, it's this blue line, the directrix, and a given point, the focus. And you can see here these green lines that distance right there is the same as that distance right there. And I could do that a lot of places. I could sit here and I could draw it up to here, and that distance should be the same as that distance. Or I could come here and go, that distance is the same as that distance. So that's the idea between or finding all these different points that would fall in the parabola, that their distances stay consistent there. So let's just kind of sketch a big parabola here, because there's an important part of this parabola with this focus and this directrix that we need to recognize. And so if this is my focus, it's always in the cup of the parabola. And then since it has to be equidistant, this distance down to here has to be consistent to the distance to the focus. So I'm going to say the directrix is probably about right here. And so the directrix is always out. It's a line that's outside of the parabola. That parabola will never touch it. Okay, so this is a special point on the parabola. That's our vertex. Now, this distance right here between the focus and the directrix has a special value. How far that focus gets away from the vertex determines how wide this parabola ends up being. So if the focus is really, really close to the vertex, then I'm going to have a skinny parabola. And as that focus gets farther and farther away, it's going to be a wider parabola. That distance from the focus to the vertex, we notate with a p. That p, it has to do with how wide or skinny your parabola is. And if you remember from your from the equation of a parabola, that a value in front also has something to do with how skinny or wide a parabola is. So that p and that a have a relationship. Okay, so, and we'll look at an equation here in a minute, but well, maybe I'll just throw it up here. So remember, the equation of a parabola looks something like this. And this a value right here is the one that determines how skinny or wide it is. So this a and this p have a relationship. They're not the same number, but a actually ends up being equal to 1 over 4 times p. Likewise, you could rearrange that a little bit and get p by itself and say p is equal to 1 over 4a. Either one of those relationships, we can use those. It kind of depends on what we're looking for and what we're given. So for instance, if I already know what p is and I'm looking for a, I'd probably use this little equation. If I already knew the a and I was looking for the p, then I'd probably use this equation. Just whichever one is set up nicer for what I'm wanting to do. All right, so let's look at an equation here where we're going to sketch it. We're going to find the vertex, the focus, directrix, and the axis of symmetry. So a lot of stuff. The first part of this is all review. Remember how to graph this. So this right here moves us left and right. We do the opposite because we're inside the parabola. So I'm going to move right 1, and then I'm going to move down 2, and that is my vertex. So right 1 down here. Here's the vertex of my parabola. Now, the other thing that we're going to do is go back and look at what the shape of this parabola is. So with a 1/8 here, that's going to be a pretty wide parabola. Remember our table that we set up. For a parabola, the parent graph just goes 1, 1, 2, 4, 3, 9, and so forth. Okay. But since we have a 1/8 here, we take all of our y values. They're going to be 1/8 of what they are in that table. So I'm going to take them times 1/8. Now, here's the thing is, none of those really multiply by 1/8 awesomely, but so that's going to turn into an over 1 up 1/8. Okay, that's really hard to notate. It's going to be hardly anything. All right, so we got that point. I could do the 4, because 4 times 1/8 is just 1/2. So that means over 2 up a half. And the 9 is not very pretty, but you know what would work nicely is like a 4/16. That'd be the next set. And I can take 16 times 1/8, a little bit nicer. So that's over 4 up 2. And then I'm going to probably, oops, that was only over 3. Over 4 up 2. And I'm going to call that good for my graph. Okay, now the other things we want to find are the focus and the directrix, and those have to do with that p-value. So remember that the focus is going to be up here somewhere in the cup of the parabola, but I need to know this distance from the focus to the vertex. So since I know my a value is 1/8, so, and I'm looking for the p-value, so up here I'm going to do a little bit of work so I don't get too cluttered. P is equal to 1 over 4 times a. 4 times 1/8. Okay, 4 times 1/8 is just 1/2. So 1 divided by 1/2 is really just going to end up equaling 2. Okay, so P, that distance between the vertex and the focus, is 2 units. That's actually pretty big. It's usually a fraction for us. Okay, so that means from my vertex I'll have to go up 2, and I'll have to go down 2 to find my focus and my directrix. So my focus ends up being right here, and my directrix is 2 units the other direction. It's right here. It's a line. Okay, so let's come over here and write those things. The focus, we're writing it as an ordered pair. Looks like it ends up being over 1 up 0. And my directrix is a horizontal line. So it's going to be a y equals, and it crosses the y-axis at -4. Okay, and then the last thing we have is our axis of symmetry. That's the line that cuts your parabola right in half. It's always going to end up being perpendicular to your directrix. It's always going to go the other direction. So my axis of symmetry is a vertical line, and it crosses the x-axis at 1. And those are the 4 things that we're going to find along with our graph. Okay, let's try one more. Okay, so move through this one pretty quickly. My vertex, I have to move left 3 up 1. So left 3 up 1 is the vertex. If I look at my table, remember it's 1, 1, 2, 4, 3, 9, but I'm going to take all of these y values times a -2. That negative, remember, is going to make my parabola open upside down. So now it's over 1 down 2, over 2 down 8, and the next one's going to end up way off my graph, so I'll call that good right there. I usually like to have at least 5 points on my parabola to help show the shape of it nicely. Okay, so this time the focus is going to have to be somewhere in this area because it's inside the cup of the parabola, and my directrix will be up here somewhere. Okay, so let's go find that p-value so we know how far to go. So since I'm looking for p, I use the one where I have p equals 1 over 4 times a, so 4 times -2. Okay, so my p value is going to be -1/8. So that's a tiny amount. That means from the vertex, since p is negative, that tells me to go down, which makes sense. I already knew it was going to be down here. I'm going to have to go down 1/8. Just down a hair right there. Okay, so what will that ordered pair actually be? Well, I'm still left 3. Okay, so let me stick it in there someplace. It's not going to be very accurate, but think about it's right there. So I'm going to be left 3. And then if I was at 1 on the vertex and went down 1/8, I actually end up being at 7/8. And then my directrix, I have to go up 1/8, and it's going to be a horizontal line right here. So the directrix is a y equals, and the vertex was at 1, and then I went up 1/8, so I'm at 1 1/8 for the directrix. And then my last thing is my axis of symmetry, which is a vertical line. We usually dash that. It's just hard to show on this graph here. We dash the axis of symmetry. It's a vertical line, crosses at -3. And those are our 4 things we're finding. All right, let's mix it up a little bit. Look at this equation. Tell me what looks a little bit different on this one. Notice it's an x equals instead of a y equals, and now we have our y inside the parentheses. Okay, you may remember from Algebra 2 that that's still, well, it's kind of like a parabola, only it's a sideways parabola. Instead of this thing opening up and down or left and right, instead of it opening up and down, it will open left or to the right. Since my a value is a positive value, it's going to open to the right. All right. I'm still going to I try not to change everything by doing this. I try to just keep it kind of status quo, but it does mess some stuff up. When you look at what your vertex is going to be, your vertex, now this -2, since it's grouped with the y, that actually affects your up and down movement. So this is not left and right, this is now up and down. You're still going to do the opposite. So I'm going to go up 2. This is then going to be my left and right movement. I'll end up going left 1. That's going to get me an ordered pair, left 1 and then up 2. You want to make sure that you notice that right away, because I'm bad about it. I jump in, I just start doing the problem, and then all of a sudden I realize, oh, I wrote my vertex backwards. You got to make sure that you keep the y with the y on this. Okay, so -1, 2 is where the vertex is going to be. Now we've already said it's going to open to the right. And so I kind of go back to, and again, I'm kind of pretending it's the same old when I try to graph this. And so it's 1, 1, 2, 4, 3, 9, but I have to take all these times 3. Okay, so what I do with this, it's really not going to be the y's times 3. It's actually the x's that are 3 times what they're supposed to be. So what I do with this is I know that that's the general shape of it, and then I just turn my graph sideways, and I graph it sideways. And so when I look at it, I'm thinking, all right, so I'm going to go over 1, up 1, even though it's kind of, remember, you're looking at, turn your head sideways, look at it sideways, 1, 1, and then I'm going to go 2, oh, well, it'd be 2, 1, 2, 3, 4. But remember, we're going to have to take all those things times 3, right? So let's try it, and let's put in some points. So over 1, up 1, 2, 3. And then I'm going to go over 2, up 12. Okay, so that's going to end up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, just outside of my graph. Okay, and then put your other point there, and everything else is going to fall off of the graph, so we'll just stop there with those 5 points and sketch the parabola. Okay, so basically just turning my head sideways to graph those. All right, so then the next thing I have is my focus, and so I'm looking for P. So I'm going to go 1 over 4 times 3. Okay, so P is going to end up equaling 1/12. Okay, so that's a tiny little amount. Remember, the skinnier your parabola, the smaller that P value is, so that kind of makes sense. So from this vertex, I'm going to have to go this way, just 1/12 of a unit, and that's going to be where my focus is. And then I'm going to go 1/12 the other direction and draw a line. And that's my directrix. Okay, so let's see if we can figure out what that focus ordered pair is. All right, so how far left is it? Well, the vertex is left 1 right there. but then I had to move it 1/12 of a unit this way to put that focus in there. So that focus is actually left not 1, but left 11/12. And then it's still up 2. For your directrix, the vertex was at 1, and then we had to move this way 1/12 of a unit. So the directrix this time is vertical, so it's going to be an x equals 1 and 1/12. Okay, last one, axis of symmetry. It's going to go through the middle of the parabola. This time it's a horizontal line, so it's going to be a y equals 2. There we go. Okay, so be careful with the sideways ones. Maybe make note on your homework right away which ones are going to open sideways. If it's an x equals, it's a sideways parabola. Okay, so let's try going the other way. So for each one of these, we'll practice like graphing it and finding all the stuff, and then we're going to also go the other way where they give us the stuff and we have to come up with the equation. Okay, so here we go. What I have on this one is the vertex. That's going to be helpful. And then I have some random point up here that this is going to go through. All right, so that has to fit into my equation. It's also opening sideways here, so that should tell me that I should have an equation that goes x equals instead of an equation that starts y equals. Okay, so let's go ahead. I've got my vertex at -2, 3. So when I write my equation, it's going to start off and look like this. X equals a, it's actually a y minus k. K actually always stays with the y value, and then it's a plus h out at the end. But we can go ahead and fill in those values for the vertex. So it's x equals a, and then it's going to be a y, and the y value is a +3, so I'm going to put in -3. And then the x value is a -2. Okay, so the only thing really missing here is to figure out that a value. That a value tells you the shape, how wide it is, and that's why they gave us this point, because this point has to go through or has to work in this equation. Okay, I'm going to first start off one way here, because some of you are good enough with your number sense that you can do this part kind of in your head. Now, if you think of looking at this sideways, so turn it so you're looking at it sideways and think, okay, how much over, how much up did we go? Okay, so I started off and I was up 3 right here, and then I went up to this one is up 6. So I just went up 3, it looks like, to get here. And I know in a parabola that it's supposed to be 3, 9. Did I go 9 this direction? Well, I was at -2 and I ended up going to -5. So I only went 3 units. And I actually went 3 units left, so that's actually a negative was what that would end up being, which I kind of knew was going to be a negative anyway. Okay, so instead of going 3, 9, I went 3, 3. So can you figure out what this fraction would have to be if you only went 3 out of the 9 units you were supposed to go? You went 3/9 of that distance, or 1/3. Okay, so your a value should be 1/3, and in fact it will be a -1/3. Now that's great. If you can do that in your head, that's super, go for it. I'm going to go ahead and go through it though. Let's say that that doesn't make sense to you, or that maybe didn't come out quite as pretty, because it's not always going to come out quite that nice. So let's look at how you would do this algebraically. Basically, I'm just going to grab this point right here, and that's my x and my y that I'm going to plug into my equation, and then all I'll have left is that a value. So I'm going to put in a -5 equals a times 6 minus 3 squared minus 2. Okay, so the first thing I'm going to do is always move that 2 over to the other side, so let's add the 2 here. And I would have a -3 equals a times 6 minus 3 is 3, squared is 9. Divide both sides by 9. Oh, looky, there's that negative 3/9. Okay, so a ends up being negative 1/3. All right, so then come back. Let's write our equation. We're going to grab that negative 1/3 and we're going to go plug it in for our a. So our final answer will be x equals negative 1/3. Then I have my y minus 3 squared minus 2. All right, let's try one more. Okay, this time I'm going to give you some information, but it's going to be a little bit different. So on this one, I'm going to tell you the vertex again. That's good. That helps. And then I'm going to tell you what the directrix is. Okay, so that directrix is actually going to help me find my p-value. So if I can find p, then I can find a for my equation. So this will be a different way to find the a. Now, I typically like to sketch a picture of what's going on here just because that way I can kind of see how this is all oriented. So when I look at a graph, my vertex is over 5, up 3, somewhere like right there. This directrix is going to tell me how this parabola opens. The directrix is x equals 2. So it's a vertical line at 2. So it's somewhere like right here. Okay, so if that's my directrix, my parabola is going to have to open like this then. Okay, so it's a sideways parabola. All right, so let's write this equation. We start off like this. And let's fill in what we know. We know the vertex. So I can do that quick and easy. All right, so then the next thing we have to do is figure out that a value. All right, so a, and I should have drawn these differently. It's hard sometimes when this is my directrix, this is my parabola. So this distance right here is p. Okay, so can we figure out what that distance is? This equation right here was at 2, right? X equals 2. And this ordered pair right here was at 5, 3. So if I'm at 2 and then I go over to 5, that distance right there ends up being 3 units. Okay, so if P is 3, let's go back. This time I'm looking for A, so I'm going to use that other formula. I'm going to say A is equal to 1 over 4 times P. Okay, because this time I know the P and I'm looking for the A. So basically A ends up being 1 over 4 times 3, or 1/12. So that's my A value. So let's go back and plug that into our equation. So it's an X equals 1/12 y minus 3 squared plus 5. There you have it. All right, good luck.